All right, a little bit of sequential stuff. I think we did see a little bit of this, just a tiny bit in one of the sections. Maybe it was a couple of them. Let's go over this just because we're seeing it though. Yeah, in my head, I was looking at addition on this one, which I think it should work, by the way. Like this one, I'd say, look, from 5 to 15, you would have added 10 right there, right? And then from 15 to 45, you would have added 30. So in my mind, just using addition, that means that we should add 50 to the next one. But I don't think that works. I don't think it works. Maybe two numbers just really isn't enough to show a pattern with those, especially with a changing pattern like this. So I'm going to ignore the addition part on this, okay? And yes, this is part of the multiplication unit and division. So if I see increasing numbers like this in this unit, I should be thinking, well, what I'm going to multiply the 5 by something to get 15, and then multiply it by something to get 45, and hopefully it's the same thing. If it is, then that shows the pattern. But where the second example shows decreasing values, I should know that I should be using division. We'll get to that one. So 5 to 15, right? I'd say 5 times what is 15? Okay, and this kind of creates a little. I like to show this on the bottom with these little arrows, right? Like what would I multiply 5 to get 15? That's 3, right? And we should have our multiplication tables up to that, from 5 up to 15, hopefully by now. So 5 times 3 is 15. Now, if the pattern holds, that means that I should take the 15, and if I multiplied it by 3, I should get 45. But let's just double check. Okay, and yeah, you could use a fact family to change this one into a division problem. I'm not going to do that just because if we see it multiplied by 3 here, then I should expect it to happen again because this should be forming a pattern. So yeah, what do we get when we multiply 15 by 3? 3 times 5 is 15. Carry the 1. 3 times 1 is 3, plus the 1 we carried over makes 45. It does. So 15 times 45, I'm sorry, 15 times 3 is 45. Which means that if I multiply 45 by 3, I should get this last number. So let's go ahead and do that. It's the 45. I'll use the red one because that's the one we got. Multiply this by 3. Well, 3 times 5 is 15. Carry the 1. 3 times 4 there is 12, but add the 1 that we carried over. Going to make that 13. So our final product here is 135, and that would be the fourth term in this set of numbers. So on this one, yeah, with the decreasing values, I should expect division, right? And you could say, well, like 24, it'd be like saying you're going to subtract 12 from 24. So 12, if I subtracted 6 from 12, I'd get 6. And for me, I would say, well, look, see how that's being cut in half right there, which means that I would take away half of 6, then this 6 right here. And so that would be my next value. And I believe it is. But I want to confirm it. Let's see if using division will help us on this, okay? So I'd say, look, you got the 24. We're going to make it into 12, right? So that's 24 divided by what is 12? Well, I got to put the right numbers on there. 24 divided by what is 12? That's what I meant. Well, 24 divided by 2 is that 12, right? So you'd say, well, 24, you could have just divided by 2, not with a addition sign, but division. There we go. Divide that by 2. Now, again, I would expect that if we took 12 and divided it by 2, we would get 6. And sure enough, 12 divided by 2 actually is 6. So when you take 6 here and then wanted to find the missing value, you take 6. All you're going to do is divide it by 2. And 6 divided by 2 is 3, just like we got in green. So this pattern held up. I think it was a little bit more noticeable, even if you use the subtraction. But the division confirms that it actually is the 3 there. Yeah, I wrote that 4 there. I don't know what the heck happened on that. That's a 5. Up here, that's should have been 135. That's better. I don't know why I wrote the 4 there.